Hi everyone, my name is Katie Weislake and today I will be sharing my adventures at the UGRA. The UGRA stands for Upper Guadalupe River Authority, which is located here in Kerrville, Texas. They were created in 1939 by the Texas legislatures as a conservation and reclamation district. Their mission is to protect, develop, and manage the water quantity, quality, and sustainability in the Guadalupe River watershed in Kerrville County. Today they continue to help the public by providing information and status updates regarding the Guadalupe River and testing the community's personal samples, as well as collecting their own samples from the Guadalupe River and testing it. This map here is showing the Guadalupe River that flows into the Gulf of Mexico. Kerrville is located over here where the star is, and that is where this adventure begins. The UGRA has an abundance of jobs and responsibilities. They are NELAC accredited, which is an acronym for National Environmental Laboratory Accreditation Conference. NELAC developed NELAB, which stands for National Environmental Laboratory Accreditation Program. UGRA also has the Texas Commission on Environmental Quality, also referred to the TCEQ, certification. With these accreditations and certifications, they are able to provide full service and watershed tests for the community's independent samples as well as the UGRA collected samples. They also provide analytical services on water, wastewater, and sludge. These services include bacteriological, chemical, and biological tests. In addition to the testing and sampling, they also work by interacting with the community. They host trivia questions on Tuesdays at 4:40 p.m. on 94.3 Rev FM. They also host shirt design competitions for younger kids in Kerrville, and many more. Here are the people that are working endlessly to ensure that all the information and data provided are accurate and given in a time-sensitive manner. Ray is the general manager who runs the office. Tammy, who unfortunately did not have a photo available, is the assistant to Ray. Tara was my primary supervisor and is in charge of all the community outreach and data distribution. Travis is responsible for data sampling and collection. Nicole is the head of the lab and responsible for maintaining accreditations, ensuring the data is accurate, and the lab is in order. Fun fact, she is also a Shire University graduate. Jay is the microbiologist and Ben is the chemist in the lab. Within the lab, I was able to participate in a variety of ways, and I was primarily assigned to work in here. To further elaborate on this experience, I would clean glassware for them. Each day I was in the lab, so practically every day. Here you can see a few glasswares that I cleaned and with deionized water and hot water rinses. Next, I commonly worked on neutralizing acids and bases. I would begin this by taking the pH with the pH probe, and if it was too basic, which it most commonly was, with a pH greater than 8, then I would add sulfuric acid. If the solution was too acidic with a pH below 6, then I would add sodium hydroxide. The purpose of this was to get the solution, which is a mixture of old samples, to have a pH between 6 to 8 in order to dispose of them down the drain. It was preferable to have a pH as close to 7 as this is the most neutral. The three images to the left are considered too basic, which you can see from the blue color and with the sulfuric acid reacting and there being a color change. The last image on the right is a solution that is too acidic. You can also determine this by it being too pink and the sodium hydroxide working with also another color change. As I mentioned before, some of the samples were too basic or acidic, so they would have to be neutralized before getting disposed of in the sink. In regards to the wastewater samples, once they were done being sampled, and they are simply dumped down the sink with running water, and let me tell you, it smelled terrible. Once the samples were disposed of, the UGRA is fantastic in recycling as much as they can, which can be seen in these images. While in the lab, I was able to observe and help with a variety of tests. I was able to observe Ben using a spectrometer to determine how much iron was in the water sample. I also observed them use the ion chromatography instrument. I helped Jay run presence and absence back-T tests in the microlab, and I have also helped Ben in various ways with the total suspended solids and total dissolved solids test. Between those two tests, the most common was the TSS test. I have additionally observed Ben perform the volatile suspended solids test, which starts as a TSS test. The product of this test is seen in the middle with the residue on the bowl. Ben also commonly runs carbonaceous biochemical oxygen demand tests that last for about a week. This is due to how many steps it takes to get its final product. Lastly, I observed them run turbidity tests on many samples. When I first began at the UGRA, I was responsible for recording the temperatures in the microlab. This is one of the requirements for the NELAC accreditation, and it is to record the temperatures for all refrigerators, lab temperatures, ovens, and sample baths. These thermometers must also be calibrated. This image shows only 2 pages of many within the one refrigerator temperature book. They must record the temperature every 4 hours, and it has to be within the given range. Microlab was particularly interesting as I have never been in one outside of Schreiner before. The first image shows the incubator containing the samples. Each of these samples had a powder, which is seen in the second and third images, added to it. There are 2 different types of these powders based on how long you must incubate the sample for. The most commonly used one is the 18 hours for this lab. However, the other is 24 hours. The powder that is being added is called Collier, which is used to look for and detect for both coliform and E. coli within the sample. If the sample turns yellow, which is in the fourth image, then coliform is present. If not, then the sample will remain the original color. If the sample does turn yellow, then this means that the sample must be put under a UV light where it is seen if it glows. If it glows, then it contains E. coli. If not, then there's no E. coli present. The last image in particular is very interesting. This is very uncommon, and it's a unique situation where the test is determined invalid. After a few days, they begin to allow me to work independently. This is within portions of their samples of their test. For the TSS and TDS tests, I will be able to weigh the samples, put them and remove them from the desiccator as well as the oven. For the CBOT test, I would be responsible for weighing approximately 0.16 grams of the nitrification inhibitor, which is seen in the last 2 images. In addition to these, I would also be able to do the neutralization independently. In addition to the lab work, I was also occasionally assigned office work. While this part was not particularly fun, but it is essential. My primary focus as the intern was data entry. Another aspect of the internship was going out with Travis and doing fieldwork. We went to various locations such as Johnson Creek, Guadalupe River at Riverview Road, Goat Creek, Town Creek, Camp Meeting Creek, Third Creek, and Quinlan Creek. At each of these sites, we ran a series of tests. Before traveling, we would calibrate the device in the scene in the third image. Since most of the creeks we're sampled from are more on the basic side, we use the PS calibrators 7 and 10. The third image shows the device being calibrated at a pH of 7. We then head out to each site, collect a few samples, and run a few tests. Image 3 shows Travis using the device we calibrated in the previous slide. The test we run at each site is flow rate, temperature, pH, dissolved oxygen, and conductivity. The second image is the calibrated device that determines the temperature, pH, dissolved oxygen, and conductivity with the 3 probes. The flow rate is a longer process. We begin by using a measuring tape to get the width of the river. This is seen in the image 1. We then divide the width into about 17 to 20 sections based on how long the river is, widthwise. We then put the flow rate reader into the water at each checkpoint we made along the width. We do have to adjust the height of the reader based on the height of the water at each checkpoint, as each point in the width is different heights. These adjustments are made with what is seen in images 1 and 2. Once adjusted, the flow rate can be measured. In a different field day, we did a cleaning of the skimmers on Sidney Baker Road. These skimmers can be found on the right-hand side where the red arrow is on in the first image. The second image shows what the skimmers look like. The purpose of these are to prevent any trash or invasive plants falling into the river below. Travis cleans these once a month, especially after a storm, as they do tend to get clogged. Another interesting field day activity was installing the water and sediment control basin. The equipment records and reports to the UGRA the depth, the rainfall, and the volume of how much water is being caught within the basin. This basin is found in image 4. On the long field day, it was extremely tough and draining as it was 9 hours long with no breaks. However, I did learn a lot on this day. We partnered with the Guadalupe Blanco River Authority from Seguin and did a lot of work together. Together we collected bugs and fish in order to identify what organisms are living there. This is primarily to see if there are any invasive species, the health of the river, and what is impacting the water quality. One of the data tests we ran was based on the river divisions we measured. Similar to the flow rate, we measured and created sections. At each section, we measured the inclines at both the right and left bank. The canopy coverage using the densiometer, this device is found on the right. The left and right bank makeup, such as trees, rocks, and shrubs, and the depth of the river. The depth is also similar to the flow rate, as we used in the width of the river into the 10 sections and found the depth at each point. A really neat thing that we did was electrofishing. This is where someone wore the electrofisher device on their back and moved through the water with it set to a high voltage. The middle image demonstrates how it is to be worn. This is very dangerous because you're putting high electric currents into the water and you are standing in it. We were able to do this without being harmed because of the waders that we wear. Image 1 is not an image of us. However, it is what we did. We followed behind the guy wearing the device to catch the fish and get electrocuted. This does not kill the fish. We use this simply just for research and just to see what fish we can find within this river. We also fished using the net in the third image. We did this 7 times for more data collection at various points within the river. The last thing we did that day was go mussling for about 30 minutes. The purpose of this was to try and find the Guadalupe River mussel. However, we only found the highly invasive zebra mussel. Ultimately, I had a fantastic time in the UGRA. I stepped outside of my comfort zone, learned a lot of new information, and I was able to also grow my skills as a future biochemist. Other than that, this concludes my adventures at the UGRA. However, to learn more about them or get involved yourself, check out their website. Thank you for listening, and I hope you enjoyed learning about my adventures at the UGRA.